All right, so Jim Bollinger here, NMH. Put this on my YouTube channel, but making it for class. And I just want to talk a little bit about law of cosines. I got another video up where we look at the different situations that arise in solving triangles and what does it mean to solve a triangle? It means to find the degree measurements of all angles and the side lengths possible. We're not going to use law of cosines when we have a 90-degree triangle. We're going to use right triangle trig. We're not going to use law of cosines when we have knowledge of an angle and its opposite side length. So if it's not a 90-degree triangle and we have knowledge of an angle and its opposite side length, we're going to use the law of sines. So when do we use the law of cosines? Use the law of cosines when we have side angle side. For instance, I might have C, angle B, side length A, and in that case, I'd be solving for this length, little b. Or I might not know any of the angles. I might not have any knowledge of any angles, but I have the three side lengths. I'm going to be able to use the law of cosines to find missing degree measurements or radian measurements, probably degree measurements we'll be talking about here. And so if you want to see or understand how law of cosines works, you're going to have to do some research. You're going to have to get a little search going on why does it work? And you'll see a couple of pages of geometric applications. And it's a little tedious, and it'll take several readings perhaps to see those puzzle pieces come into fruition. I'm not sure that's the right word to use either. All right, so we're going to be in class doing law of cosines, finding angles, finding side lengths, most every day, just a little bit every day. As soon as it's in front of us, it'll be on every worksheet. You'll get a chance to, 24 hours later go, do I remember how to do this? And over time, I'm sure people get pretty good at it. That's been my experience. So don't panic if you don't get it right away. What generally gives students difficulty is this part of the law of cosines. It's usually misread. This is just a number. It's just a number, all right? Cosine C. What is cosine C? Cosine C is a number between 1 and -1. All right, so we've got a side length, another side length. Let's say this is 5 units long, this is 6 units long. Well, 5 times 6 is 30, minus 2 times 30 is minus 60, times plus or minus 1, or the fractions in between those numbers. So what's that generating? Something smaller than minus 60 or equal to minus 60. So I might be adding 60 or subtracting 60 or all the numbers in between. And of course, we've got to look at those values as well. Okay, so I said that Pythagorean theorem was a special case of the law of cosines. And C is the hypotenuse. Usually we designate C as the hypotenuse, Pythagorean relationship. And what's the angle that goes with C? 90 degrees. 90 degrees is opposite little c. Okay, so opposite gets the little c gets the big C in this formula. You'll find that it's pretty easy to memorize after a couple of tries. And what is the cosine of 90 degrees? Well, let's take a quick look. 90 to go straight up, adjacent to hypotenuse. And of course, in the unit circle, I like to say the width. And what is the width at 90 degrees? Well, we've done it enough, I hope you know it's 0. And 0 times anything is 0. There's your Pythagorean relationship that you're so familiar with. So if we have to learn the law of cosines, let me give you an example. Let's say we want to find little a, the length of little a. I should get a triangle here again. Let's see, how about I try to make one that doesn't look like 90? That's pretty good. Here's big A, here's little a. And then therefore we know something about little c and big B. So we have knowledge right here, and we're trying to find that. That's your side angle side situation. okay? So here's the law of cosine. A squared equals b squared plus c squared minus 2bc cosine big A. Cosine big A. Now, if we have to memorize something, then why not memorize one line of work? Save ourselves each and every day having to write more than we have to. Okay, so this is what I want you to memorize. For finding a, little a, which is a length, this is a length, right? For finding that length, we take the square root. Oh yes, square root. Oh yes, square root is a length. Square root's a length, so there's, stands to reason that that's a little clue as to when you're finding a length, because we're going to have two memorizations here. And this is the one that helps you remember you're looking for a length. And remember this relationship, everything else is B's and C's. Okay, so I might as well memorize that. So let's see. Let me give you a situation. How about we do a 4, 5, 6 triangle? How about that be 4? That be 5, we'll make that 7. 4, 5, oh, we don't know this. Okay, I'm guessing it's around 7. And what do you think? Maybe 100 degrees? Keep everything nice and integer friendly. Okay, so 100 degrees. What do you think the cosine of 100 degrees is? Can you get a feeling for the cosine of 100 degrees? Okay, well, there's the reference angle, right? There's your 100 degrees. And we're looking at what? This is 1. The width. So what is that width? Looks negative to me. How about we say negative 0.33? Rough estimate. Okay? So what would this be? Negative 0.33. I mean, I don't have a calculator now, right? B, let's call this B. We'll call this 5. We'll call this 4. This is 5 times 4. Let's just cut to the chase, make it 20. All right, so what are we looking at? 25 and 16, some quick math, 41, minus a third. This is about a third, right? A negative times a negative is a positive. So that's a third of 40. 2 times 20 is 40. A third of 40. Why don't we call it 13? So we got 41 plus 13, a square root. What's that? 54? What's the square root of 54? Well, it's a little bit bigger than 7. Now, I hope you see I was just playing with some approximations here, but hopefully you can see that I'm arriving at a justifiable answer. Of course, you're going to go to a calculator. I'm just playing. All right, you're going to go to a calculator. All right, so let's say I give you a chance to do your first memorization, and then we'll look at the other situation. All right, so let's say we have this triangle. Bumpity, bumpity, bumpity. And let's say that this is, let's go with this one right here. I'm going to say that that's, I'm going to go 29 degrees. Like I know, I don't. Let's make this 8. Oh, this is long. Let's make that 11, 12, oh God, 13. I'm going to say 13. And so now we're trying to figure this out. Okay, I'm not even using A, B's, and C's right now. Side, angle, side. So what do we have? Question mark. Length is equal to the square root of what? 8 squared plus 13 squared minus 2 times 8 times 13 times the cosine of 29 degrees. Of course, I need a calculator, right? For some good accuracy. That's it. That's simple. Now, that was finding a side length. What if we wanted to find the angle? What if we didn't know that that was 29 degrees? And that this was, what do you think? 10? I'm guessing here. Okay, maybe that's 10. How would we find this angle? We'll call it angle A. Oh, well, I guess that's angle A, right? And so now we know this is 10. Looks like we've got to solve an equation. Looks like there's only one unknown in this equation. I guess we can use inverse operations. So maybe I should do it in the general sense. No, I'll use these numbers just for the heck of it. So what's the first thing you're going to do? You're going to move the square root to the other side. I like to change the sign of everything. So I'm going to say that, I'm going to move minus 2, 8, 13 cosine A to this side, make it positive. I always like to work with positive variables. 2 times 8 times 13 cosine of A is equal to 8 squared plus 13 squared minus 10 squared. There, I haven't lost track of anything. Okay, we're still trying to isolate A. How about we take this multiplication here? Remember, cosine A is just plus or minus some number. I mean, we can call it X. Cosine A is just a number. We'll call it X. Okay, or we'll call it what? I don't know. We'll call it cosine A because that's what it is. Okay. And that's an operation, by the way. We got to isolate this. All right, so we're going to divide by, I think I'm going to erase. Is that okay? Yes, it's okay because it's my house. 2, 8, 13 multiplication, division. 2, 8, 13. Boy, we still got big A and little a at the ends. Isn't that interesting? Well, I guess I got to undo cosine. Well, cosine is angle to ratio. I wonder what operation takes angle to ratio. What operation takes ratio to angle? Oh, yes, the inverse cosine. Takes this ratio, 8 squared plus 13 squared minus 10 squared, over 2 times 8 times 10. And you write that on your answer keys on my test, you get credit. Bingo. You don't have to do it out. I trust if you can do that, you can work with a calculator, come up with an answer. Okay, I want you to remember this. Okay, so now I'll do it in the general sense. All right, and we'll show you the 2 things you have to learn, and then we'll summarize one more time what you have to do here. All right, so we'll summarize. So that's A, that's little a. This is B, we'll call this little b, then that's big B. And then this is big C and little c, and they always look alike to me. All right, so side, side, side. Let's pretend we don't have any of these angles. Let's see. Which angle do we want to solve for? I like B. Big B. So what is big B? Oh, big B is an angle. What does it come from? Oh, angles come from cosine inverse of ratios. Oh, the cosine inverse of a ratio gives me an angle on a calculator. Ratios have fraction bars. I'm on a roll here. Oh, so what are we trying to find? Big B. Oh, I remember. Little b and big B always are at the ends of this one-step calculation. I mean, we could do it out each and every time, but why do that? Why not memorize, cut to the chase? So I've used improperly. It's actually going to be b squared. Now that I've gotten that straightened out, let's continue. Oh, I've used b squared. I wonder what would go in front of b squared. Probably a squared and c squared. And if I only use little b once in the ratio, 2ac. There's a jingle there, huh? That gets us started. Now, if we're going to talk about that day in and day out forever, as in probably 40 days, trimester, I haven't even counted the number of days. But I got a feeling that if we just do this a minute a day, 2 minutes a day, that we will effortlessly learn how to do this within a week. Maybe a little longer, but if you put the time and effort into looking at this again tomorrow, you've looked at it today, that's enough. Close it down, look at it again tomorrow, you probably own it. And if you don't do that, you probably won't own it. So it's up to you. You want to own it or not. But it's a question of whether or not you want to get one of these from me or not. So there's your law of cosines. When do we use it? Not when we have 90-degree triangles. I won't give you any credit for any solving of a 90-degree triangle. I don't usually do that. I like, people looking at things from different perspectives, and I think that's great. But in this case, I want to hold you accountable to doing it the easiest way. All right, you got a 90-degree triangle. We're going to use right triangle trig. Okay, and we'll be practicing that in class. If you have a triangle that has an angle and its opposite side known to you, but it's not 90 degrees, you are going to use law of sines. And if you don't have either of those situations, if you have side, 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 or side angle side, then we're going to use the law of cosines to find missing angular measurements and missing side lengths of triangles. Okay, which was a stepping stone to other interesting mathematical calculations historically. Okay, so I guess that's that. And I will post this, and I hope you look at it. Be careful, be safe, take care, bye-bye.